Hey guys, this is Mr. Schechter. I'm going to try to review some nomenclature with you guys. This is going to be an unedited video, so yeah, just browse it as you please. Stop whenever you want to. If I'm going over a problem and you want to look over the answer, stop it. This is going to be the first part in the series. First, I'm going to start off with binary covalent compounds. Then I'm going to go over to ionic compounds, first with only one charge, then with more than one charge. I'm going to move on to maybe a brief review on polyatomic ions and then end off with some acids. So let's get started. So this is binary covalent compounds. Binary covalent, by the name, it'll tell you right here. You see that there's two different types of atoms, okay? However, the covalent part tells you that it's going to be a nonmetal and a nonmetal, always. So in all of these examples, H2O, Ci4, BrO3, CH4, what you're going to see is you're going to see two different types of atoms, okay? So for example, in H2O, we have a hydrogen and an oxygen. Both of them are nonmetals, okay? And that's basically it. Ci4, you have a carbon and an iodine. BrO3, you have a bromine and oxygen, so on and so forth. As far as naming this goes, naming H2O as an acid would actually be okay, because even though it's still a binary covalent compound, it has an H in front, which means that it is an acid. It is an acid technically. So if I were to indicate, for example, name binary covalent compounds, to name H2O as a binary covalent compound, you just name it dihydrogen monoxide. So remember that for the binary covalent compounds, and these are just two different atoms again, with both being nonmetals, what you're going to do is you're going to use the Greek prefixes, okay? So as you see for H2O, there's two H's, two hydrogens. We're going to make it dihydrogen. We have one oxygen. We're going to make it monoxide. Hope you guys can see that. Monoxide. So moving on to Ci4, okay? We see a carbon. We see four iodines. So your first instinct is to maybe say, okay, for a carbon, I'm going to make it monocarbon tetraiodide. But remember that for the first atom in a compound, for the first element in a compound, so in this case carbon, we always drop the mono. Even if there's one, we just drop the mono. If there was two of these carbons, or three or four, or up to 10, we would use the name. So if it was, for example, 5, we would say pentacarbon tetraiodide. But since there's only one carbon and 4 iodines, we're going to say carbon tetraiodide. Remember that binary covalent compounds always end with IDE. That's the common theme here. If you look at all these guys right here, they all end with IDE. Okay? What about this one right here? This one is BrO3. Okay? So Br, bromine. Remember, we drop the mono. O3, trioxide. Remember, we're going to make it, first it's trioxygen, then we chop off the end of oxygen and we make it ide, as we do with all of these. Okay? Some of you guys may be confused why BrO3, that may look familiar. It's actually also a polyatomic ion. But the way that you name it as a polyatomic ion, your hint is if there is a minus. If there is no minus, you must name it according to what it is. Okay? If it's a polyatomic ion, you name it from the sheet, okay, from what you guys remember. But if it's just BrO3, these two are both nonmetals, we name them accordingly, okay? We name them as binary covalent compounds. CH4, again, same rule. C, carbon, H4, tetrahydride. Okay? Let's see, for the polyatomic ions, okay? So a normal ion contains more than one atom.